Welcome everyone to the second introduction to topology. I'm Thomas, also Guilty Gyoza, and we also have Patty on the call, co-hosting this call with me. Let's get it started. So the agenda today is going to be time and protocol. We're going at a higher level for things, and hopefully this is inspiring to people, no matter if you're technical or not technical. Okay, time and protocol. Let's do it. Time is interesting. This is from Tenet, a sci-fi movie released in 2020 by Christopher Nolan. And it's a movie about many things, one of them being time. The movie has this mechanics of the world where everything is determined, where time is woven together. But depending on who you are and which version of you in which space-time, you will be seeing and experiencing different things. And there can be many copies of you, except they're not copies. It's just you existing in different space-time, and these space-times can coalesce and interweave in a way that you can see your counterpart, you in the future or in the past. So that's an interesting way of thinking about time. Time is important in blockchain. In a way, Bitcoin is time. In the original paper, Bitcoin is a solution to timestamping, and it is a timestamp server that's able to count the ordering of events that transpire in the Bitcoin universe, and to be able to do that without relying on a single server. Right? So that is the major contribution of the Bitcoin blockchain. So Bitcoin is time, but as we know, there are different constructs of time. So what specific time is the Bitcoin's time? Well, Bitcoin's time is a linear notion of time, where at every moment in time, you know everything in the universe. So on Bitcoin, everything in the universe is what's in that block on the blockchain, right? So if you open a block of a Bitcoin, you can find UTXOs. These are events that have transpired on the Bitcoin blockchain, and UTXOs are just fancy technical ways to say who has sent how much coin to which other person. That's UTXO for you. In the Bitcoin universe, things are transactions, and transactions are who spent how much on which receiver. Okay, so Bitcoin's time is linear, and it basically assumes this absolute space-time where at any moment in time, you know everything globally of the Bitcoin universe. But that isn't the only construction of time, and not the most interesting one. So we also have relativity. In the early 1900s, it has been realized that information can travel only as fast as the speed of light. And so if you do something there and the light hasn't traveled to where I am, then there's no possible way I can learn that you have done what you did. Light is the upper bound of information travel. Okay, and light also has a constant speed, right? So in vacuum, the speed of light is 300 million meters per second, roughly speaking. And that is a constant, meaning that speed of light does not change. And so it's interesting to think about this scenario where you have the rocket on the top, a light goes up to the top mirror, goes down to the detector, right? So it goes by these distances. Whereas in the middle situation, you have the rockets moving, and you will think that light goes travels a longer distance to reach the mirror and travels a yet longer distance to go down and reach the detector, right? So it takes different time for light to reach the detector if a rocket is moving or if the rocket is not moving. Now the situation is the rocket moving or not moving? That is a question that is meaningless unless I know where you're asking the question from. If you are in the rocket is not moving for you because you're in the rocket. You're part of it. So the rocket is static for you. But if you're outside the rocket observing the situation, then the rocket is moving for you, right? And therefore, how much time does it take for light to reach the detector? This question is meaningless to answer unless we know where you are observing from. Are you inside the rocket or are you outside the rocket? That determines if the rocket is moving, and that determines how long does the light need to travel. Okay, and that is an interesting concept. It's so interesting it breaks most people's view of the universe because time seems to be absolute, but in this case, time seems to be relative after all. It depends on where you're observing from. Which brings us to a very interesting model for understanding time that is called light cone. A light cone, and I'm borrowing this video from YouTube, one of the best explainer videos of this concept. Light cone is the idea of understanding how far can information travel in the future and also from the past. Okay, so you have a light cone. The original point is where a piece of information happened or an event that has happened. The light cone, the lower cone going to the bottom, it contains all possible events that could have caused your event at the origin. The slope of those lines are the speed of light. The reason why light cones are light cones is because the bottom light cone describes all possible information from the past that could have caused your information, which means it could have played a part in causing your information. The upper light cone is your future light cone, where your information will be able to influence in the future. Okay, horizontal is space, vertical is time. What's outside of the light cone is impossible for your event to be influenced or to be influencing. Okay, so the shaded part below the y-axis are those areas contain information that could have not contributed to your information. Because for them to be influencing your information, they need to be traveling faster than light, and that is impossible. So those events are irrelevant to you. They're independent of you. And also for the upper part of the shaded areas, those are space-time where your event or your information has no part in influencing. They're independent of you. Okay. This is interesting because it allows time to be considered in a way that is not invincible and not instant. It takes time for information to travel, right? It takes time for people to learn of certain things happening elsewhere. Okay. And there is a technology that precisely captures this mechanics of understanding the universe, and that is called CRDT. It is a super mouthful, but it is a data type. It is a data type that is designed in a way that precisely captures the idea that our universe does not respect a single notion of time. Time depends on where you are observing from. It is a modern notion of time. And guess what? Guess what happened when we embraced relativity? Guess what happened in early 1900s? We began to explore the universe, right? And human footprints began to spread beyond our planet. This actually means that relativity is crucial for us to understand phenomena that are way macro and way of a much bigger scale than our planetary scale. It's important for us to begin to understand the cosmos. like the real Cosmos, the Cosmos blockchain. And for us to go beyond our regular scale, we need to embrace relativity. That's the point here. If in our reality, embracing relativity is how we go beyond the planet and start understanding the universe at a grander scale, CRDT is the technology that allows us to build way bigger systems where more people are interacting and more people are expecting to participate in the same universe. You have to have a relativistic universe to be way bigger and have way more people and actors in it. The CRDT is the key technology enabling that. That's why we're using the technology. This is the prototype that we built a year ago using YJS, which is a open source JavaScript CRDT library. We use it to build this game where everyone is a penguin and everyone interacts with everyone else without relying on any intermediary servers or any blockchains. This demo was made just between the laptops of our team members, connecting directly to one another, right, peer-to-peer. And the fundamental construct of this game world is a CRDT provided by YJS, and we programmed the CRDT so that it represents the world of the game. Okay, so we made this to have belief in how this approach can work, which brought us to protocol. Why are we making a protocol? There are a lot of decentralized protocols. Okay, since the 1980s, we have a long line of decentralized protocols invented. So this is Usenet, which uses the UUCP protocol for transferring information between Unix computers. And this was how Usenet, a news protocol, was built using UUCP. The idea is that back in 1980s, we don't yet have personal computing ubiquitous yet. So in the sense that you don't have smartphones, most people in the world do not have computers, and there are powerful machines, which are the big boxes, the three big boxes in this picture. They are participating in Usenet directly. So they're exchanging news information under different news topic. And the terminals on the peripheral are users. These are weak machines. And the purpose of these weak machines is for users to publish news under topics and to read news from certain topics. And the machines will figure out who is interested in what topic and who is publishing information to which topic and exchanging information accordingly. And this is a distributed protocol working across machines. Okay. And then 9 years later, we have the World Wide Web, which nowadays we just call it the web, or most people just call it the internet. You go on the internet, by default, you're going to surf the web. Originally, it was just this picture capturing its entire design, which is you have servers and you have clients, and servers are supposed to provide information to clients on request, and information is structured as hypertext documents. And the way clients and server interacts is via the HTTP protocol, which is in front of the URL that we type in the browser input box every day. Well, nowadays it's HTTPS, but this is the HTTP protocol. Anyone is supposed to be able to run servers that can open up to any clients. So this is a distributed protocol. And then we have Napster. Napster is the idea that, hey, can I serve my file not only from my server, but from any client that already has the same file? The thing is, can users exchange files directly between themselves without always having to go back to the original server where they got the files from? And that is the idea of Napster, but in its specific case, it was for music sharing. The problem with that is you have a server that is the bottleneck of the entire system, and Aster was eventually shut down. This is not to advocate that piracy is good, but this is to look at the vulnerability of the system just from a technical level. So can we solve the server problem here? Okay, so we have BitTorrent a couple years later, and it was the idea of being able to find where the files sit in which computer and to be able to request the files from that computer and to have a lot of computers collectively holding files together. So it's difficult to take files down once they are distributed like wildfire across the network. You still have servers here and there that are facilitating certain things, but things are much more distributed in this case. And on top of that, BitTorrent also has a upper layer feature that requires people to perform tit for tat. So the idea is, if I want to ask for files from the BitTorrent network, I also need to contribute myself to the network. So if I want to download things, I need to also upload things. So I become part of the network that is serving things to other people. And that is pretty cool, right? And that is still working without cryptocurrency involved. You can have a decentralized protocol that works in a super distributed and decentralized fashion without needing a cryptocurrency. It has its own problems, and a lot of the tokenomics design, it comes down to solving incentives problem for the networks to behave as intended. You have BitTorrent being a live example where cryptocurrency is not involved. So you can have distributed protocol working without cryptocurrencies. It's really nice. You also have IPFS. IPFS is a protocol for serving data blobs or data blocks in a distributed fashion. So data blocks are can be redundantly held by the network of IPFS nodes. Every piece of information is unequivocally identified by its content ID. So if you give an ID, it will uniquely identify a piece of file. And the network is able to understand, just by you giving them the CID, the content ID, who in the network, which IPFS nodes in the network have the information corresponding to your CID. And you can retrieve from those computers. And these can be any computers. These aren't necessarily super powerful, professionally managed servers. You can run an IPFS node on your own computer too. So this is yet another distributed protocol that works in a marvelously decentralized fashion, also without a cryptocurrency. But we have a lot of blockchains that work because of cryptocurrency. I think this basically shows us that the landscape of decentralized protocols is really wide. And that brought us to the mission of Topology Protocol, which is to take this wonderful technology called CRDT, which has existed for decades, since 2008, but more popularly since the early 2010s. A technology that has been adopted in databases, in collaborative editing, in big corporations synchronizing their clients, and big corporations synchronizing their servers. We take this technology and we want to make it as an internet protocol. An internet protocol that is standard on the internet by default. So the mission of Topology Protocol is we want to make the internet real-time by default. Remember, CRDT is a technology that embraces relativity, right? And the reason why we want to embrace relativity is because we want to explore the greater cosmos. We want to build bigger worlds at bigger scale where more people and more actors can get involved. So Topology Protocol uses that technology so we can make real-time applications work for more people in real time, and we wish the internet has been that way. To this date, there is no protocol on the internet that leverages CRDT to make internet a real-time to make internet a place for real-time applications. There are a lot of CRDT solutions, but it has not been standardized on the internet. We are hoping to drive the process of standardizing CRDTs on the internet. So this is the long-term aspiration for Topology Protocol, is to have sufficient adoption and interest and use cases in areas and implementations in different environments and runtime, so that Topology Protocol becomes justified to be submitted to the Internet Engineering Task Force as an RFC, a request for comment, so that we can begin the process of standardizing Topology Protocol into the standard Internet Protocol suite. And if that happens, and when that happens, the internet will be experienced in a very different way than how it is now. Nowadays, we go to the internet, we expect to read information that people written on the internet in the past. We're always reading sort of dead information. When you read it, it already came from the past. When the internet is real-time by default, you go online expecting to hang out and interact with people in real time, always, and content feels alive, everything is responsive. That is the future we believe in, and we're making a protocol to express this is the kind of internet we want, and we think what the world needs. If you haven't joined our Telegram group chat, come join us. It's Topology Friends. And for those of you who are interested in contributing, all our code bases are open sourced under Topology Foundation on GitHub. That's the intro to Topology call for today, and we're happy to answer any questions.
We had some reactions during the presentation in the chat. And right now we just had a comment from Kono saying that Zaki just joined. And GG for presidency. It's a great presentation by L. Okay, he joined the Telegram group. Yes, I didn't see him here.
Feel free to ask us any questions. Stuff that is outside of this presentation, that's fine too.
Yeah, right now the group is saying to make topology great again with the US president. Now we have a question. T. Delabru asked, are you developing topology specs first or implementation first?
We are currently implementation only, in the sense that there is a short list of core protocol features that we want to make sure they work. And the way we make sure they work is we implement them first. So we're currently implementing everything in TypeScript. Under the Topology Foundation organization, you can find TS Topology. That is our TypeScript implementation of the protocol. And that includes all the existing implemented core features. We have a couple more core features we want to implement before we move on to spec. And the reason for writing a spec is for two reasons. So our team members are suffering a lot because of TypeScript, and they want to move to Rust. So when we have a spec, we can justify moving over to Rust and begin creating a Rust implementation of the protocol and having the TypeScript node and the Rust node interoperating. The second reason is the core feature that we want to implement before moving on is actually really, really important, in the sense that the relationship between blockchains and Topology Protocol is that we want to make the pie bigger for everyone. So topology does not differentiate between any blockchain. It wishes to complement any blockchain. The idea is that CROs and smart contracts can hang out nicely. They can send information to each other and then hang out. The problem is on blockchain, things are really unforgiving, right? If you send a transaction on a blockchain, you're not expecting to get it back. You can't really reverse it unless you do low-level attack, which is really hard and expensive. So when you want a CRO to trigger a transaction on a smart contract anywhere, on any blockchain, you want to be careful what information are being sent from a CRO to a smart contract. That information better come from some kind of agreement between the parties that are involved in your CRO. So that is a distributed agreement problem. Another way to say that is it is a finality problem. So our current plan is we want to get this done, a good first solution in TypeScript before we call it a day and we move to spec. And then from then on, it will be multiple implementations and the spec evolving in parallel continuously. Does that answer your question?
He did add a follow-up question. Yeah, it answered his question. And before he did say, I believe that Elixir could be a good lang for an implementation and then reaction of heart to Rust. Oak said that the question for Tim is what the fuck TypeScript? But I think you answered the question. If you want to comment something else, otherwise there is another question.
Yep.
Yeah. Nice. The next question is from Tim again. What are the core mechanisms you want to test beforehand?
Core mechanisms. I guess you mean the core features we want to test before writing the spec. If that is the question, I think the most important thing we want to do now in terms of core protocol feature is finality.
Mm-hmm.
So again, finality is a way for people in the same CRO to reach agreement on what they know about the CRO. And if they have agreement, such agreement can travel elsewhere and trigger something else.
I just realized this is Timothy. Okay. Nice. Yeah, does it answer your question? Yes, it does. So we had another question from Dudes asking, can people who are not programmers contribute? Is there a way?
I think there are actually a lot of ways to do that. I think there's some of the things that we can do on our side is to help bootstrap a community of artists and creators that can create stuff with CROs and Topology Protocol without having good technical knowledge as a requirement. And I think if we help reach that stage of the ecosystem, we can have people contributing a lot and doing interesting stuff and exploring without knowing technical stuff. But I think there's a lot of stuff on our side that we need to make happen first. So one of the things would be great documentations and great examples. With great examples, you can then take them and change them a little bit and make it work differently. And that is a way to help people that don't have super deep technical knowledge to still play with Topology Protocol. I think another way to really help Topology Protocol is to ask us really hard questions about what everything means and to write about it. And I don't mean technical documentations. I mean write-ups and blog posts and contents in different form, conversational or otherwise, that discuss any topic related to Topology Protocol. What is its potential in terms of giving more freedom to creators? What is its potential to change how social media works? What is the potential of Topology Protocol to change the process of making games collaboratively, potentially with the communities together? So then game making becomes not just the job of the game developer, but also together with the player community. How can Topology Protocol enable that? I think a lot of these topics are super interesting, and they really require people that have deep curiosity in these areas, and these are not technical areas. These are more like areas about community engagements and how does a creative medium become useful for new forms of art and creations. I think those questions are not technical. It belongs to media theory and art theory, and those are super important areas that can help Topology Protocol as well. I think when the internet becomes real-time and people can tinker together and have presence, the process at which people contribute to the internet will be very, very different. And thinking about that difference, I think, is going to be really interesting. And I think a lot of discussions can be had there. And most of them probably are not technical at all. I think as a recommendation, I would suggest there is a website called interconnected.org. That website summarizes a lot of deep thinking about the future of the internet, what could be different. And particularly, I think that website is championing this idea that internet could be places, like it should be places all along. It should not be documents where people consume information. It should be places where people hang out and create together. And I think that website did a tremendous job collecting thoughts, pieces, and materials along the topic. It's rethinking what the internet can be in the future. So I recommend checking that website out and any related materials.
Timothy shared the future of the internet.org as well.
Nice.
So thanks. I think that answers the question. And maybe you want to talk about the blog posts, because they are also very friendly for artists in the non-technical sense.
So we have company blog posts. They're hosted at the website blog.topology.gg. So if you go to that website, currently there are 2 blog posts published there, and they are written with the intention of explaining and communicating with people without technical knowledge. So we hope those blog posts are interesting and helpful.
Right. So just to confirm, is it futureoftheinternet.org or interconnected.org, the one that you mentioned?
I may have remembered the URL incorrectly, but I have interconnected.org in my head.
Okay.
It is
No, later
actually,
when we upload the video, we can make sure that the right link is there as a comment.
Yeah. let me check my. It's okay. So the URL is interconnected.org. It's the author is called Matt Webb.
Right, so it's this one. Yeah. I see your
So if you go to interconnected.org, it's interesting because you have cursor party enabled on the website. Cursor party means that I'm on the website with my phone now, and you can see cursors, multiple cursors on the screen with a national flag next to it, showing where the user is visiting the website from. And that is basically Matt's idea of making his website a place, not a document, right? So if it's a place, if you go to a place, you should be able to see other people that are also at the place.
I love that. Nice. And it's very interesting that you talked so much about physics and light and movement, and it's also about space in time. So it makes sense as a whole. We had another question. Oh, yes. Sorry, El. We have another question. Is are CROs climate sustainable?
Well, it doesn't. I think it's pretty sustainable, right? Because it doesn't need miners and it doesn't need staking and it doesn't require third-party servers, machines that are not related to the party that you're hosting to run. So I think it's the most climate sustainable protocol that can be possibly created.
Well said that it's interesting. It's amazing. It was interesting. It became amazing. And someone else is typing. Maybe a question. Okay, another question. Is topology mainly for live connections, or could it also work for online, offline syncs? And the question is by SO Lab.
Online, offline scenes. I wasn't sure entirely what that means, but I can still give you my thoughts. So CROs can allow scenarios where you don't expect people to be interacting in real time. It's actually fine. We're making the protocol with the intention of enabling real time because that's really hard. And if we solve that problem, we will have changed the internet forever. But the protocol also supports offline first interaction in a sense that if you do stuff to your CRO while being offline, and I do stuff to the same CRO also being offline, and then we both come online and synchronize our stuff, CROs can guarantee that our stuff actually merges, so we both see the same thing and everything operates correctly. So it allows people to collaborate without necessarily staying online always. That's why the technology has been traditionally used for collaborative editing, where people can go online and offline, and everything still works nicely. But I think we really have this emphasis of going real time because that's really hard and really interesting if enabled. Does that answer your question? Feel free to ask follow-ups.
Yeah, he clarified the question as like peers joining where there's a large difference in local data. And then he said that yes, it answered the question.
Right. I think that can be a little bit nuanced, but the short answer is yes, entirely. The slightly longer answer is depending on your application, you may have to be very careful when you have guys that are making a bunch of changes offline and coming online, flooding everyone with the changes. Okay, so that may be problematic. In your application or in your CRO, you need to have logic taking care of what happens when that happens. And I think we also need to do some work on the protocol side to enable you to do that. It will be important if, so for example, in a video game, if you have in a competitive game and you have people going offline in 5 seconds, doing a bunch of things, and then come back online, those updates are really problematic, right? Because those updates were done without the knowledge of everything that happens elsewhere. So the protocol side needs to give you some help for you to program in your CRO and say, okay, if these things are happened a long time ago, you can define what long time ago means for you. Then you can expire them or handle them differently. But if you're creating a collaborative editing application, then it may make sense to always be accepting updates, even when they were generated while offline. So it really depends on your applications, and we are hoping to enable it.
Nice. We have another question, which is from Timothy. How would you build a chat with CROs or apps where other order matters?
Yes. So how to build a chat room application with a CRO? We actually already have it as an example under the TS Topology repo. The short answer is you can rely on local timestamps. So if you rely on local timestamps, you use that as a way to order things. Well, then I don't think you're happy because you come from the blockchain space. So you're trust minimizing. The idea is that local timestamps can be not trustworthy at all. I think this really depends on your application. So in a chat room, you may have certain trust assumptions. Typically, people don't invite random people to their chat rooms. And so if you have people in your chat rooms that you trust because they belong to the chat room in the first place, and they started to go Byzantine, they started to run weird clients that are playing with timestamps and they're injecting messages here and there, then it's probably time for you to kick those people out, right? So I think that's one way to do that. There are other ways to do that. So you can say, okay, we don't rely on timestamp to sort the messages. I think we're still assuming that when you make a chat application, the messages are supposed to be linearized, like in a waterfall fashion. I'm thinking you're not happy with a chat room where messages look like a graph, right? It will be quite weird. Maybe fun for you. I don't know. Let me know. But I'm expecting you're not very happy about that. So if you want your chat room still in a waterfall linear fashion, you need a way to order the messages in a hash graph. So I'm assuming you know that hash graph is the way we are representing operation history of a CRO. In a hash graph, you can have things that are not ordered because they're not comparable. So how to order things that are not ordered? You can have your custom rules. You can say, okay, when people are sending messages that appear to be concurrent from the graph, we are going to order the messages according to their ID alphabetically. And if that is not good enough, we can use other ways to tie break so that we always have a deterministic way of sorting the messages and show them in a waterfall. And I think in chat messages, it's way more forgiving. I think in a money application, the order at which you execute a transaction is super important. In messaging, I think it is much more forgiving. So I think having a good deterministic algorithm for sorting, tie breaking the messages when they're concurrent, I think is good enough for chat application. But you can let me know if that still makes you unhappy.
Right. So we had some comments in the chat while you were explaining. I will briefly go over them. And we had Oakset mentioned large group chats. And then Timothy asked if you can rely on the hash of the last message seen. Oak said like community chats, you can still have concurrency there in the hash of the last message seen. Then Timothy said yes, but only partially, like a DAG. And then Oak said that yes, we are using the hash graph, which is a DAG, the one that you just talked about. And then we have a comment from Timothy again. I would be very curious to use a chat app where you end up with a graph of messages rather than a single line. Slack kind of does this when you can answer to a message starting a thread.
Yeah. Well, now you have threads that can interweave, so it's more like a braid. Yeah, but you can definitely do that. I think we'll be interested in seeing someone such as you do that and demonstrate its user experience.
Timothy said it would be visually really fun and great illustration of CROs to see that.
Yeah.
Yeah. Nice. We have a few more minutes. Maybe if you have a final question, there's time for one last question. Maybe not. Okay. Nice. So this call will be shared in our YouTube and our Twitter, so you can follow, so you can watch it again. And we have this call every month with small tweaks, so you can join next time and also invite more friends to join. I think everybody's in the Telegram already, but if you're not, you can just join the Telegram. We shared the link already. And yes, it's been very fun. Thanks for coming, everyone.
Thank you, Patty.
Thank you.
Thank you, everyone.
Thank you, Giri, for giving us this, hosting the call and giving us all the teachings.
Cheers, everyone. Hope to see you in our next community call.
Yes, next week we have a community call. See you then. All right. Bye.
Bye.